In this example, we're going to study a singly linked list, and yeah, let's do this. So let's first start this example creating a simple file. I'm going to use Vim here. The first step on any C file is definitely including the headers, in this case standard input and output. We start with a main function, and this function returns an integer, so that's why returning 0 here. Now we're going to define a struct. From people that are more used to modern languages, you can define as a kind of like an object. It's basically a different data structure that we're going to call here node, and this node, it's going to have basically two informations: integer, which will represent the number or ID of this node, and I'm gonna have a reference to the next node. That's why I'm creating another structure here called struct node, and I'm pointing to the next node. That's why I have this star here. And for this, we need to define a function that will create this node in memory. As you can see, this function here returns a pointer and receives simple integer that will represent the data in our node structure, right? For this memory allocation here, we're gonna use malloc. The reason why we're using malloc, it's basically to dynamically allocate memory, a space in memory. And always when you allocate memory, you need to check if that thing worked. One more information interesting here, as you can see, I passed size of node. This function will pretty much calculate the amount of memory that requires to allocate a single node in memory. After I get this NP, which is how I call this node object here, I can pretty much assign a value, and for the first option here, I'm gonna just point the next node to null. This, of course, can be changed in order to elaborate more in the linked list. As you can see, I was getting a warning here for malloc, so I need to include another header, which is a standard library. This way the warning will just appear. Okay, now we have the function here, new node. We need to actually create some nodes. So in the main function, we're gonna create node 1, node 2, and we're gonna assign two different values here. Actually, let's add another one, node 3, new node, and pass the integer 3. Now that we have those objects, we can point the next node from node n1 pointing to node 2, and node n2 pointing to the node 3. In this case, node 3 is not pointing to anyone, so what's going to happen is it's a linked list that it's not going to return to the first element or to anyone. So it's just one node pointing to another one, to point to another one, and ending to def null. Now let's compile this guy. I'm gonna use GCC here. GCC, it's pretty standard in Linux, you can use that, but I'm gonna pass another variable here, which is -g. This variable will allow me to debug this program. So GDB is the one I want to try here, and now let's set a breakpoint to the main function. In GDB, you can actually start a visual mode, as you can see here, and once you're in the visual mode, you can see where in your execution of your program you can stop, and you can investigate pretty much the values of variables. As you can see here, I'm checking the value of n1. I can check the reference, the address that it points to. I can also print the entire object. I keep saying object, but yeah, you got it, the structure, right? Yeah, as you can see next here, it's pointing to nothing. That's why we see 0, but as you can see in the previous nodes, we can see some other references here. Yeah, in order to check the value of next, we need to print with this little star here, which is actually gonna print the object that this address points to. Yeah, this is pretty much linked lists, and you can also inspect the entire memory. You just pass X, and then you pass the number of hexadecimal value, the elements that you want to see. So in this case, I'm going to print 20 decimals, and you can change that to hexadecimal and other number formats. That's all. Hope you enjoy. See you later.